Okay, 1.3 says determine the area of RPT over the area of RNM. Okay, remember the answers that we got yesterday, we may need them to answer this question. So let's look at the two triangles. We have got triangle RPT, that's RPT. Okay, then the second one is RNM. It's RNM. Those are the two triangles. What do you notice about the two? They share a common vertex. What else? They share they share a common angle, which is this angle here. No. Remember, they are not the same. We have got RPT. This is RPT. And we have got RNM. They don't share a common base. And they don't share a common height because the two bases of those two triangles are not on the same line.
Oh.
Yes.
This one we use the area rule.
Yes, you can use the area rule here. But for you to use the area rule, you need the dimensions of MR and NR. Now, if you go back to yesterday, okay, Shisha was not here, unfortunately. If you go back to yesterday, but you have no excuse for even though you were not here yesterday, right? MN is equal to 24. Okay, I'm going to add that to the question. Then TP is equal to what? To 9. So this is 9, that's 24. Furthermore, based on what we did yesterday, I found the ratio of RT over RM. That is RT over RM. I found that yesterday. You agree with me on that? So I can just take that. It was 3 over 8. But take note, this is a ratio. This 3 over, it's not a length. Okay, it's a what? A ratio. So if it's 3 over 8, then I can add it on the diagram like this. The ratio of its it's what? It's RT and RM. If it's 3 over 8, then I can call this one here, say 3x. It means RM is going to be 8 what? 8x. Do you get that? The ratio of RT over RM is equal to 3 over 8. I got it from yesterday. I calculated from yesterday. Were you in class yesterday?
Yes, I was.
I calculated this yesterday. And I got 3 over 8. 3 over 8 is just a ratio. Okay? RM is the full length of the side of the triangle. You see that here? We have got RM. RT is part of RM. Do you agree with me on that?
Yes.
So if I call RT 3x, it means RM will be what? 8x. And also, yesterday I proved, if you go back here, I proved that the two triangles are what? Are similar. If the two triangles are similar, what does that mean in terms of the ratios of the corresponding sides?
Equal.
They are equal. Okay? So if I want to calculate the area, the ratio of the areas of those two triangles, right? I can use the area rule, but if I use the area rule, I'm going to need the length of RM, the length of RT. I will also need the length of RP and RN. Fortunately, I can also use the proportion theorem in this big triangle here. Okay, using the length of RM and RT. Then I can find the ratio of RP to RN. And then I can carry on from there. So allow me to use the proportion theorem to determine the ratio of Rp over Rn. Because already I know the ratio of Rt over Rn. Do you agree with me on that?
Yes.
So let me use the proportion theorem first. Okay, there's more than one way of doing the question, but let me use the proportion theorem. So I'm going to say in triangle, that will be triangle, I'll call it RMN. Okay, triangle what? RMN. If I use my proportion theorem, I can say Rp over Rn is equal to Rt over Rm. Then my reason will be line parallel to one side of triangle. You agree with me on this? Huh?
Yes.
Then my ratio of Rp over Rn is going to be equal to Rt, which is 3x, and my Rm is 8x. So the answer there will be 3 over 8. Okay? So the ratio of Rp over Rn is also 3 over 8. Now I want you to be aware that the proportion theorem and similar triangles, they can be joined two together sometimes when you're answering some questions. You have to connect the two, proportion theorem and similar triangles. So if I want to find the area now, I want you to look at what I'm going to do. I'm going to use the area rule to get this ratio of those two. Okay? So on the next page, I'm going to say area of RPT of triangle RPT, okay, is equal to. Do you agree with me that if I use the area rule, it's going to be half RT times RP? Do you agree with me on that? RT times what? RP times the half. Sine what? Sine R. So I can write that as a half times RT times RP sine of the angle R. Then the second one, that is the area of RMM. Area of triangle RNM is going to be equal to a half. Okay? Look here. If this is the common angle, it means it's going to be equal to a half times Rm times Rn times sine what? Sine R. So it will be Rm to be times Rm times Rn. Please take note this is M here. Let me rewrite it nicely. This is Rm times Rn sine R. Okay? You following? Huh? I'm using the area rule from grade 11. Fortunately, these two will cancel, those two will cancel. Now check this. This RT over the Rm, I can split this up and write it as RT over Rm times Rp over Rn. And the good thing is that both of them are equal to 3 over what? 3 over 8. So RT over Rm is 3 over 8 times Rp over Rn is going to be equal to 3 over 8, which is the same as 3 over 8 squared. And the final answer will be 9 over 64. Okay? No, it's fine if you just want to say 3 times 3, 9, 8 times 8, 64 is okay. But the reason why I wrote this is because I want to tell you something very important with regard to two triangles that are similar. The ratio of the areas of two triangles that are similar is equal to the ratio of any one side of any corresponding sides of that triangle squared. So if you square the ratio of any pair of corresponding sides, you get the ratio of the areas. Let me show you the diagram. Maybe you will understand. You see, do you agree with me that the two triangles are similar? From yesterday, when you hear yesterday? Okay, I proved here. Yeah, that the two triangles are what? Are similar triangles. If they are similar, it means that the ratios of their corresponding sides are what? Are equal. So if you write their ratios, yeah, like this. You see what I wrote here? Right? If you take one of them, like say PT over NM, you know the value of that ratio. If you want to determine the ratio of their areas, all you have to do is square this ratio or square that ratio because they are equal, or you can square that ratio. Like for example, let's say PT over NM is equal to a half. If that's the ratio of those two sides, it means the ratio of the areas of the triangles will be a half or what? All squared. That's a very important result. It is only true for similar what? Triangles. Remember, the ratios of the corresponding sides of similar triangles are the same. So if you know any one of the three ratios, you can use that ratio to determine the ratio of the areas of those two triangles by squaring the ratio of the sides. Right? There I was talking. I want you to go home and figure out another way of getting this answer that I got. Right? That's your homework as well. I'll give you another question. You go home, go and figure out another way of getting that answer.